like this now. 50 kilometer per hour. That means 50 is written in the numerator now. That is 50 is over here and 1 hour is here. No, we need to. So which relation is true here? We know that speed equals to distance time. We can write it like this also. Or we can say it like this also. Time equals to distance upon speed. Can we say it like this? Yes.
Yes, sir.
Okay. If you were to see now, this formula has actually been written in the option. Just option is not just a bit confusing. It's confusing you guys, I believe.
Well, can you explain again?
I'm saying that we know speed equals to distance upon time. Yeah.
Yes.
Right. If you were to find time, you would write distance upon speed then.
Yes.
Right. Or if we're using the same formula, can I not write this? Distance equals to speed multiplied time. Simply I'm transposing the values here. Okay. I am just transposing the values. So just remember the basic formula, speed equals to distance upon time. Okay. So the
Yes.
first option is obviously wrong here. Second option, that is time equals to speed upon distance, but time is equal to distance upon speed now.
Distance upon speed.
Yes,
So
sir.
second one is also wrong. The third option is, it is like this: 1 upon time multiplied by distance. It is same as distance upon time. There you guys got confused. Okay. This is the sign of multiplication here. Okay now.
Okay, sir.
Getting it now. So which option is correct?
Sir,
Third
C.
C. Okay. Now observe this figure, guys. Chakrika, please read the question.
Oh, yes, sir. The time period of a simple pendulum is the time taken by it to travel from. So should I also read the options?
No need to read the option. All three of you,
Okay.
please have a look at the options and do answer it. Okay.
Sir, it's the first one.
It's the first one.
Yes, sir.
Hmm. Okay. Or can there be multiple options that is correct here?
Sir, I think it's B.
It's B, 0 to A to B, and then B
Yes,
to A.
sir.
No. Had the option been like this now, 0 to A, then A to B, and then B to O, then it would have been correct. But here that is not the case. So this one is wrong here. Okay. Look at option number C here. That is saying B to A. From here to here, and then A to B, and then B to O. No, that's a bit extra oscillation. Oscillation we can calculate in two ways. You guys know time period of a simple pendulum is the time taken by it to complete one oscillation, no? Right?
Yes, sir.
Here we are basically talking about oscillation. When we talk about the motion of this bob here, we are actually talking about the oscillation. And one oscillation in terms of pendulum is the motion done by this bob to either, I'm saying either, to move from A to B and come back from B to A. That is option number A to B and back to A. Okay.
Yes, sir.
Or either we can see that it moves from 0 to A. Remember, 0 to A, and then from A to B, and then back to 0. I repeat, from 0 to A, then from A to B, and then back from B to A. Let me write it over here. It is 0 to A. Okay, 0 to A, then A to B, A to B, and back to 0 from where it started. It started from 0, moving from 0, travel to A, from A to B, and then back to 0. Hope that is clear. So option number A is the only correct one. Okay, now have a look at
Okay,
C
sir.
number. That will be also wrong. B to A. That is from B to A to B, and B to 0. No, that is wrong. Yes, Sundus, is that clear?
Yes, sir.
Hmm, good. Now, have a look at the time now. Yes, you guys give a definition of time. How do we define time? Give your definition according to your understandings. Yes. Yes. Vaiga, starting from you, define time.
So like time has only one direction,
Hmm,
forward.
good. Good. Or
Uh,
what else?
So we cannot reverse time.
We cannot reverse it. Right. Good. Or what else? Is time relative?
Uh,
Hmm? Is time relative? Yes. Have you have you guys seen
so yes.
sci-fi space movies? Have you guys seen the Interstellar? Interstellar, it's a space movie where you
no, sir,
see,
I don't think so.
where you get to know that the time is relative in nature. Look here, just to
I
give an example.
didn't see it.
Okay, no issue. Okay, basic things we know that time is basically it's a movement from past to present to future, right? It is continuously moving in the forward direction, as Vaiga said. Time always moves forward and cannot be reversed, right? You cannot go back in time. It's a continuous process, right? Then we know that time is measured in different units like seconds, in minutes, in hours, right? Now,
Yes, sir.
okay, earlier we had different methods to measure the times. Nowadays we have got more advanced methods and more accurate methods to measure time, right? Now, one more aspect about time is that time is relative. What do I mean by this? Time is relative. Now, an interesting concept here is that pay very close attention here. Say there are not two identical brothers here. Okay, two identical boys are there, boy A and boy B. Yeah, yes. Are you guys there or not?
Yes, sir, we are
Suppose,
Yes,
there.
sir, we are.
hmm, suppose, suppose at certain point in their life, like they both of them are of 10 years age, 10 years and 10 years, right? The boy A here is in Earth, and suppose the boy B, I made him sit in a spacecraft whose speed is almost equivalent to light. Whose speed is almost equivalent to light. Say this is a, let's say, a spacecraft in which the boy has been forcefully made to sit. Okay, now, and its speed is almost equal to light, right? And suppose I sent him in a journey in space for like just 5 minutes. Okay, I sent the boy B in a space journey for just 5 minutes, sitting in this spacecraft that is moving almost at a speed equal to light. By the way, you know the speed of light is 3 times 3 multiplied 10 raised to the 8 meter
Yes,
per
sir.
second, right? So imagine that is a very big speed, right? So with this speed, this boy is moving in the space in this spacecraft, and when the boy comes back in 5 minutes, so he would, the age of this boy would be 10 years 5 minutes, while his identical brother would have almost like age to 40 years. Getting getting it or not? What I'm trying to say here. Hmm?
Yes, sir.
Sir,
Copy.
sir,
Hmm?
can you just repeat again?
Yeah, again, I will be repeating, no issue. They were two identical boys, okay, na? Sundus, Chakrika, and Vaiga. Both of their ages were 10 years, right? What I did now, this boy, I made him forcefully sit on this spacecraft, okay? And let's say I made the spacecraft run at a speed almost equivalent to light, almost equal to light. With this speed, this spacecraft is moving in the space for 5 minutes, for 5 minutes, let's say, okay. Okay. Now, after 5 minutes, this boy comes back on Earth. His age would be just 10 years, 5 minutes. Okay. But the age of his identical brother, it might be not very exact, it might be 40 years now. What basically happened here? Time moved very slow for this boy here on Earth, while time moved very fast for this boy on this
Oh, okay, sir.
space, on this
Okay, okay.
spacecraft. Yeah, Chakrika, Vaigan, Sundus got it or not?
Yes, sir, got it.
That is why we say that time is a relative concept if we were to talk about it in astronomical terms. For someone, it is very fast, for someone, it is very slow. It depends with which speed you are moving in space,
Okay,
right
sir.
now. Hmm. So, how do we measure times? There are many events in nature that repeat after a time interval. For example, morning, sun repeats, the rising of the sun. So our Earth is doing rotation every 24 hours. Due to the rotation, we see the morning. So basically, the day and night, that is due to the rotation of the Earth, right? Also, we say that day and night, the time gap between the day and night, it's the time between the sunrise and the sunset. Hmm. So time between the sunrise and the sunset, it's almost equal to 12 hours. So that is also one way to measure time, the gap between sunrise and set. Earlier, this is how the times were being measured. Okay, if it's rising of the sun, it means morning. Even now, it's
Okay.
the same thing, but then you don't had the watches. Then month is bit earlier. We used to count a month as the time between two new moons, as the time between two new moons. Okay, yes, Chakrika. We were measuring times. So many events in nature, looking at them also, we can measure times because these events are repeating themselves
Excuse me, sir.
after a time interval. Yes. Yeah, Chikrika. You were away for a while. Yeah. Chikrika, you were saying something?
Yes, sir. Actually, I got disconnected, so I had to leave the meeting.
Okay, okay.
So, what
What
did
was
you
the
say
point?
before?
Yeah. Did you got this point which we discussed
No,
about?
sir.
No. Okay,
You were
okay.
just asking me like, what's the meaning of time? So that's it. After that, I got
Oh,
disconnected.
okay, okay. Look, let me quickly revise what we discussed. We know time is the
Yes.
movement from past to present to future. It always moves in the forward direction. There's no going back in time. Okay. Now, then I say that
Yes, sir.
time is a relative concept. What does it mean? Like, if you have an example of two identical boys, A and B, and their age is 10 years, right? Why B, if he was to be made to sit in the spacecraft that is moving almost equivalent to the speed of light, that is 3 raised to the power, 3 multiplied 10 raised to the power 8 meter per second, if he were to be moving at this speed in space in the universe for let's say just 5 minutes and then come back to Earth, okay, his age would be just 10 years and 5 minutes, but his identical brother would have aged 30 years more than him, that is 40 years. So thereby we see that time, it's a relative concept. So for this boy B, time moved at a fast speed, but for boy here on Earth, time moved very slow. So that's why he aged 40 years. Is it clear?
Yes, sir.
Okay. Then we know that time can be measured by looking at the different events happening in nature as well, like the morning, day and night. There's a fixed gap between day and night now. Then the month is taken as the time between two new moons, right? So you have got the new moon. Okay. So from here you go to the full moon, right now. Full moon, that almost takes 14 days now, from new moon to full moon, and then back from full moon to coming to the new moon, it again takes 14 days, right now.
Yes.
Getting it now. So almost that is equivalent to a number of days in a month, that is 30, almost equivalent, we can say it. So in that manner also we measure time. What about year? How do we measure year, Chakrika? Yes, Vaiga? Hmm. Yes.
Sun, the sun do one revolution around the sun. Sorry, the earth they do one revolution around
Mhm.
365 days.
Exactly. Good, Sundus. So year, it has been said, like the time the earth takes to complete its one revolution around the earth, that is 365.6 days, right? Good. Then now we have different measuring instruments to measure the time. Okay. So clocks, it works on the concept of periodic motion to measure the time. And it means that it uses motion that repeats itself in equal amounts of time. Remember the periodic motion we discussed in the beginning. Okay, and there are
Yes, sir.
different types of measuring devices. For example, you have got an example of sundial here. Yeah,
Yes, sir.
this is an example of sundial. On what principle the sundial work? Do you guys know?
Yes, sir. Like due to the position of the
Hmm.
like the sun.
The shadows were
Yes, sir.
falling on particular numbers here. Thereby, we got to know about the particular time of the day. Getting it now?
Yes, sir.
Okay. Yeah. Guys, are you having some network problems? Sundus, network connection सही है आपका?
हाँ सर थोड़ा प्रॉब्लम
Okay. Okay. No issue. So, time. Then the second device which you are getting here, that is a sand clock. Okay. They all had
Yes.
certain problems. We will get to know all of them were having some limitations. They were not very accurate. For example, using a sand clock, you could measure times up to like only 5 minutes, okay, or 10 minutes, or 30 minutes, or an hour only,
So we can
right?
also measure 1 hour.
1 hour, right? The limitation about it is that we basically, when you when you were using sand clock, it actually just measures the time gap. Okay, it's like a stopwatch, right?
Yes,
Now,
sir.
earlier people used to use it like a stopwatch, more of a stopwatch rather than a um, um, clock. Getting it now? So it does not shows the specific time of the day, right? Getting it now? Then you have this interesting water clock here. Can anyone explain to me how it might be working? How it was working back
So
in the
I
day?
didn't learn about this.
Mm-hmm. Okay, if you were to see it now, there are numbers mentioned over it. Dear Sundos and Vaiga, Chakrika,
Yes,
and
sir.
from one side,
Yes, sir.
water is being poured into this funnel-like shaped structure, funnel-shaped
Yes.
structure, and there are certain numbers like 1, 2, 3, 4, 5, 6,
sir
7,
I think
up
Till
to
like
12.
12.
once if it got poured so
Hmm.
like 1 hour is passed from like one and then
Hmm.
2 hours
Hmm.
like
Exactly. Okay, like if this much of level of this container is emptied, it means that certain amount of time has passed. Then the second, if the water level came down to the second number, then it also means that okay, this much of time might have passed, right? Now,
Oh yeah.
so
Okay, sir.
in that manner, the time was measured using the water clock. Then you had got the modern days clocks like the pendulum, which we work on the phenomena of pendulum. This
Yes,
one
sir.
works on the pendulum, while this one it's a quartz watch. Quartz, it's nothing, it's but a stone. It's a crystal.
Oh, okay, sir.
Quartz company, the quartz company, basically it's named after the quartz crystal used in the watches. Okay, now. So how this functions? Basically, this quartz crystal, it vibrates at a very high speed. Okay, it vibrates, and based on that vibration, the mechanism of the quartz watch is based. Getting it now?
Yeah, sir. Okay, sir.
Okay. No. What were the limitations with the sundial? Limitations. What were the problems if you were to use sundial today, or even back in the time? What problems would we face? Like, it works, it measures time by the position of the shadow that is casted by the sun.
Yes, sir.
It works
So like if
on
it's raining
hmm,
and or like they cannot check
exactly.
the
Hmm,
clock.
exactly. If it's a cloudy weather, then there will be no shadow casted on it. Then how would we get to know the time, right? So
Yes,
it was
sir.
working on the position of shadow casted, okay, na, by the sun. But there were limitations if the weather is cloudy, right?
Sir,
Oh. Mm-hmm.
so but then we can also use other natural sources, I mean, artificial resources of light, right?
We can use it, but you see, the artificial resource which you would use to light it and cast a shadow would be not giving you proper time. It will be having errors in it. Now, for example, if you were to burn a candle in this direction, right, so you will be casting shadow on this side now. But the thing is that the okay, suppose someday you placed a candle here. Now if some other person were to place a candle over here, other one were to place a candle over here, so we will be getting multiple readings now. Hmm?
Yeah, sir.
But the sun is fixed there in the space now. Hmm? sun is Sun is also like doing motion in the Milky Way galaxy. Sun is also like doing motion. You guys know about it now. Sun is not stationary. Sun, along with
Yes, sir.
all the planets, they are also moving in the Milky Way galaxy. None of the bodies in the universe is fixed. All of them is in motion, continuously
Yes,
motion.
sir.
They are
They're
doing
not in
continuous
rest
motion.
motion.
Exactly. Right now. So that is the problem with it, Chakrika. Okay.
Okay.
Then in the same case, sand clock also had certain limitations. It worked on the flow of sand from one glass bulb to the another in order to measure time, right? So it also had certain problems. Okay. And the rate at which water was coming out from this pipe and the rate at which it was getting emptied, okay, that showed you the time in the case of water clock, right? Now, so all of them had certain limitations. So nowadays we use the quartz
So,
watches and the digital watches. Yeah.
so
Yes,
what
sir.
are the limitations for the water clock again?
Water clock, yes. For the water clock, suppose it's a sunny day, it's a summer season, so thereby what will happen, the rate of evaporation of water will increase now. Yeah,
Yes, sir, yes, sir.
the rate of evaporation will increase. Now if suppose it's winter, then the water will start to freeze. Now water will simply freeze. Thereby what will
Yes, sir.
happen, no water will come out through this hole. Getting it now? So those are the limitations about the water
Okay, sir.
clock as well, right? Okay, now let's talk a bit about the units. Normally the units that we use to measure time in our daily uses are generally in second, minute and hour. Okay. But apart from that, we have got other units also. Second, hour and minute is there. 1 hour, by the way, is equal to how many minutes?
60.
60
60.
minutes.
60 minutes.
1 minute equals to how many seconds?
60
60
seconds.
seconds.
60 seconds. Good. Other units to measure time is year, a day, a week, Tetrasecond is there, century is there, month is there.
Yes,
Okay.
sir.
Then there are certain other units also which are not very important for you to
Sir,
remember.
it's
You can remember
terasecond, right?
decade. It's terasecond, yeah.
Okay, sir.
Terasecond. 10 years, that is a decade. Century, that is 100 year. Right. Then there's a Julian. Decasecond is there. Right. Leap year, in which the month of February is of 29 days. Then you have got the
Yes, sir.
millisecond or megasecond, right? Or the calendar year of 12 months, right? So there are several units to measure time, but the only important
Yes.
ones are second, minutes, and hours. Okay,
Yes, sir.
getting it now. Okay, so you see, all these different units of time are used depending on the need actually. Okay, like how much of time period gap we need to measure. Based on that, we will be selecting the unit. For example, if you were to measure gaps between new moon and another new moon, then you will be using what? The month, no? Right? Okay.
Yes.
So based on our need, we use different units, right? Now,
Yes, sir.
nowadays, you see the most clocks and watches have got what? They have got electric circuit in them. Okay. They have got electric circuit in them. A cell is installed in it. And these are what? These are the quartz clocks basically, right? And then you have got the smart watches as well, which does not work on a quartz. Rather
Yes,
than
sir.
that, it is it works on the international time zone. Okay, now. Okay, so with this, basically the chapter finishes here. I have got few questions for you guys. Let's have a look at them. Okay, shall I assign the questions, or all of you would like to attempt the same questions at a time? Shall I assign questions individually? How do you guys like to move? Like, shall I assign questions like to first question to Sundus, then the second one to Vaiga, or all of you would like to do the same question? Let's do one thing now. Let me assign questions to you. Okay now.
Okay, sir.
Or you guys can pick questions yourself as well. Pick questions from 1, 2, and 3 yourself. Vaiga, which one you would pick?
So,
Quickly.
like, I'll choose first one.
Which one?
First one.
First one. Okay, Vaiga. Chakrika?
So the second one.
Yeah, Sundus?
Third year.
Okay. What are the answers?
So, for the first one, it's B, speed is equal to distance by time.
Speed equals to distance upon time. Okay.
Yes, sir.
Chakrika? Basic
So
unit of
it's
speed is
meter per second.
meter per
It's meter
second.
per second.
Meter per second. Good. Question number 3. Sundus, solve it and do tell me how you solve it. While you, Vaiga, for
Yes, sir.
question number 4,
Yeah.
I'm changing the value here from 2 kilometer per hour to 6 kilometer per hour. Okay.
Okay, sir.
And then find the answer.
Okay, sir.
Okay. Chakrika, question number 5. What would be the answer?
So it's odometer.
That is odometer. Good. And if you were to measure the speed, that is
Speedometer.
speedometer. Good. Yes, on this turn.
So can you just give me 1 more minute?
Okay, sure. Take your time.
So, like, in the fourth one, I have to find the like meter per second, right?
In meter per second.
Okay.
You have to find it in the meter per second. Chakrika, meanwhile, you look at question number 7 also. Okay, now. Question number 7. Look at this one.
Yes, sir. Sir, it's kilometer per hour, right?
Kilometer per hour, right? Have you seen the
So actually, can you
sun
explain the fifth one?
fifth one?
No, fourth
Okay.
one.
Fourth one. Okay.
Sir, I found it. Found the answer of the fourth one.
Fourth one. What is the answer? For 6 kilometer per hour.
Sir, it's 5/3.
It's 5 by
5 kilometer.
per 3 hour.
Yes, sir.
Okay, okay. Or we can find it in the decimal also. Almost 1.7. It would be approximate value would be 1.7 kilometer per hour. Always try to find the answer in terms of 1 hour.
So can
Okay.
you just explain it?
Yeah, sure. Let me do it. Okay. 6 kilometer upon 1 hour. We are required to convert it into meter. So here we are moving from kilometer towards a meter, from bigger unit to a smaller unit. So you need to multiply it with 1000 simply. Right now?
Yes,
And
sir.
from hour, we need to convert it to first minutes. So thereby we first multiply it with 60 because we know 1 hour equals to 60 minutes. Again, the answers are in second. So we again convert into second. Thereby multiplying it with 2 times with 60. 6 and 6 gets cancelled here. 10 upon 6. You are left with 10 upon 6. Right? Okay. As Chakrika said, that is 5 upon 3 or 1.68 or 1.7 kilometer per hour. Yeah,
So we
Vaiga
can
is
also use. So we can also use 5/18.
5
Right?
by 18. Simple thing as that. Simply multiply
Okay,
it
sir.
with 5 upon 18. That will be 5
Okay,
upon
sir.
3. Okay. But you need to know this method also. Although the method is very simple because many times students confuse 5 upon 18, whether it's 5 upon 18 or 18 upon 5. They get the answer wrong then.
Okay,
Okay,
sir.
now. Now, Chakrika, look at question number. Vaiga, you look at question number 8. Chakrika, question number 9.
Okay,
Okay.
sir.
Yeah, Sundus, coming back to you. Have you solved the question? Yes, Sundus.
I'm solving it.
Okay, solving it. Okay. You know which formula has to be used here? Yes. Distance, look here, the question number 3 is that you need to find the total distance covered by the car.
Sir,
Speed.
I was a little bit close.
Okay. Okay. If you're a little bit close, then keep solving it. Okay. When you're done, let me know. Okay, now. Coming back to you,
So
Vaiga,
the
which question you were solving?
like the eighth one, so it's Delhi.
Delhi. Okay. So the ancient time is in device sundial at Jantar Mantar is in Delhi, obviously. Okay,
Yes, sir.
Chakrika, the
So
time taken.
this is
So
also in
okay,
Jaipur,
done. Now.
It is in.
Delhi and Jaipur, right?
It is in Delhi. About Jaipur, I'm not very sure. Okay, now.
Okay, sir.
Yes, Chakrika.
So same at all times.
Yeah, the time taken by pendulum of given length to complete one oscillation is same at all time. Exactly. Okay, now.
Okay,
The
sir.
time taken by pendulum of given length.
Got the answer.
The answer is how much?
35 kilometers.
Okay, please explain the steps that you use to solve the question.
So I did 15 divided by 60, and then the answer I got was 0.25, and I then multiplied it with 80 into 0.25, and then I added with.
Okay. Tell me one thing, that did you use this formula? Distance equals to speed multiplied time. Speed multiplied time here. Okay, just
I tried, but I was something else.
Okay. Speed equals to, okay, what's happening? Just give me a moment. Yeah. Speed equals to distance. Just give me a moment. Question number 3, in which you guys also have a look at this question. A car is moving with a speed of 80 km per hour for 15 minutes. For 15 minutes, it moves with a speed of 80 km per hour. And then again for the next 15 minutes, it moves with a speed of 60 km per hour, right? So we need to find the total distance. Speed and time is given. So we know the formula speed equals to distance upon time. Thereby using the same formula, I can find that distance equals to speed multiplied time. Getting it now? So here distance will be total speed multiplied total taken, the total time taken. So total speed, Vaiga, you are supposed, Sundus, you were supposed to simply add the two speeds now. 80 plus 60. Also be careful about the units. Units are same, kilometer hour, kilometer hour. Getting it now? But the thing here is that the time given here is in 15 minutes. So as you said, you divided 15 by 60, right now. So 80 plus 60 multiplied 15 upon 60 plus 15 upon 60, right? Or do one thing, just multiply 15 upon 60 by 2. 140 multiplied 2 multiplied 15 upon 60. Yes, are you guys getting it? So we are left with
Can you explain again?
140.
I don't
Okay.
get it.
Okay, sure. Look here. What we are doing here now, what we are trying to find here, the question is asking to find the total distance covered by the car. Okay now.
Yes, sir.
So here the speed for the first 15 minutes is given as 80 km per hour, and then for the next 15 minutes it is 60 km per hour, right? We know the formula
Yes.
is speed equals to distance upon time. Thereby distance will be equal to speed multiplied time. Yeah.
Sir, but then here they're asking to find the distance, right? So it'll be distance equals speed into time, right?
Exactly. That's what we are doing here. Okay. So here there's not just
Oh,
one speed. There's not just one speed. Two separate speeds are given, right, on this? So we add them now. 80 plus 60 kilometer per hour. And then you need to take care of time also. So multiplied by 15 upon 60, right now, plus 15 upon 60. There are two times given here. So 140 multiplied 15 upon 60 plus 15 upon 60. That will be how much? 30 upon 60,
sir.
right? Yes.
Yes.
Yes, sir.
Very good now. So you divide it and you get it how much? 140 upon 2. So that is 70 kilometer. Getting it now? Yes. So that is the total distance covered by the car. Okay. Yes. Any confusions here?
Sir, it's 70 kilometer.
70 kilometer.
Okay, sir.
Okay. Okay, look, one thing here now. I think we have done something wrong in the question. Look here. If you guys were to look here, this formula distance equals to speed multiplied time. It's better to approach in this manner. What if we can do it in this manner? Distance equals to speed multiplied time here. Okay, but what if we were to calculate the distance covered by the vehicle in this much of portion and then again in this much of portion? Are you guys getting it what I'm trying to say here? First, find how much of distance is this much and how much of distance is this much. Let's assume it to be d1 and d2. Okay. So in this case, it will be d1 will be what? Speed into time. And d2 will be also speed into time. So here the speed is how much? Yes, Vaiga? That is 80 kilometer per hour multiplied with the time. So time is 15 minutes here. To convert into hour, we divide it with 60, right? And talking
Yes, sir.
about d2, it will be 60 multiplied 15 upon 60 again, right? So we cancel it out. Okay, let's see what answer we are getting here. So here the distance 2 is 15, while here this is how much? It is 20. D1 is 20 kilometer, while D2 is 15 kilometer. Thereby the correct answer for the question would be 20 plus 15. We simply add D1 plus D2. So that gives you 35 kilometer is the correct answer. Getting it now? Yes, Sundus. I believe you solve it using this method, right? Yeah. Yeah, Sundus, are you there or not?
This
Okay. Okay. Yeah, is the method clear to all of you?
Yes, sir, it's clear.
Okay. Chakrika, is it clear? Yeah. Chakrika, are you there in the class or not?
so sir, my method of doing it is wrong.
Did you use this method or other method? Do one thing now. After the class, send me the photo of the method which you used. Okay, now I will have a look at the steps. Okay, Sundus. After the class, make sure you send it.
Okay.
Yeah. Okay. Now moving on further. Question number 9, Sundus, you solve this one, and question number 10, Chakrika, you solve this one. Okay, so I believe question number 9 was already solved. Yeah, Chakrika, what about question number 10?
So Chakrika told the answer for ninth one.
Yeah, she already told. So you do one thing, you tell the answer of question number 10.
So it's like motion of a swing.
Motion of a
I was
swing.
only
So
one
I guess
chance.
we have already done that 10th question in a class.
Yeah, I believe we have done that already, yeah,
Yes,
in the
sir.
examples. Okay.
Yes, sir.
Now, what is a rectilinear motion? What is the average speed, and what are the uses of uniform motions? Okay, these are the questions which are generally asked in the exams. Okay, so remember them. At least make sure that you remember definition of uniform motion. What is non-uniform motion? Okay, what is
Yes, sir.
rectilinear motion, what is circular motion, and what is periodic motion, right? And how does a pendulum work? At least remember them.
Yes,
Getting
sir.
it now?
Yes, sir.
Okay, have a look at this question, Sundus. Read the question.
Which of the following cannot be used for measurement of time?
Which of the following cannot be used for measurement of time? A leaking tap, a simple pendulum's shadow of an object during the day, or blinking of eyes, on which you cannot rely. Like in certain examples, the time taken for the action performed is fixed, while for certain actions it is not fixed.
The blinking of eyes.
Leaking tap or blinking of eyes?
Blinking of eyes.
Blinking of eyes, right? Okay, then here's one more question. This question is very interesting here. There are two clocks given in the question here. Okay, now, and here the hand, yes,
Sir, why couldn't you hear me, sir?
yeah, you are audible. Am I
I'm
audible to you or
audible now.
not? Yes, Yukrika.
Sir, I was asking to explain the third question again from the past 10 minutes, sir.
Okay, okay. I believe this third question here.
Yes,
Okay.
sir.
Yeah, at that time you were not audible. Okay. I call you many times. Anyways, let me quickly explain that as well. Look here. Here the
I was
vehicle.
answering, sir, but then I guess you couldn't hear me.
Okay, okay. No issue. A car is moving was moving with a speed of 80 km per hour for the first 15 minutes, and then for the next 15 minutes it was moving at a speed of 60 km per hour. We need to find the total distance here. Total distance will be how much? So we divided the distance into two parts, d1 and d2. For the first 15 minutes, while the car was moving with this speed, how much of distance was covered? We assumed it to be d1, and the next distance covered was assumed as d2 here. We know the formula is distance equals to speed multiplied by time. So here we have taken the speed and we have taken the time also. While in the question, the time is given in minutes, so we needed to convert it into hours. So we have divided it with 60. Same thing we have done for D2 also. Okay, na Chakrika? Yeah, so
Okay,
far
sir.
clear? So here we
Yes.
got, after calculation, we got D1 as 20 kilometer. This much of distance was 20 kilometer, while D2 upon calculation, we found out to be 15 kilometer here. So the total
Okay, sir.
distance D will be D1 plus D2, that is 20 plus 15. Thereby we got 35 kilometer. Okay, now back to the question.
Okay, sir.
This question here. So in this question, guys, it is been given that there are two clocks A and B. In clock number A, it has got an hour hand, a minute hand. Clock A has got only two hands, an hour and a minute hand. Whereas this clock B has got all the three hands, hour hand, minute hand, as well as second hand. Now read the options. All three of you read the options and see which option is correct here. Using which watch you can measure the time as given in the option. Keep in mind that watch A has got only hour and minute hand, while B1 has got all three: hour, minute, and second hand. Yeah. Which option you guys think would be the correct one here? Okay.
So
Guys,
the C.
C. Time interval of
Yes, sir.
5 minutes can be measured by both A and B. Yeah.
Yes,
Yes,
sir.
Because
sir.
both of,
Correct
exactly, because both of them have got the minute hand. That's why we can be using it to measure the time interval of 5 minutes. While talking about option number A time interval of 30 seconds can be measured by clock A. No,
No,
because
sir.
it does not have a second hand. So there's no question of
Yes.
measuring second here. Then option number B, a time interval of 30 seconds cannot be measured by clock B. That is false. It can be measured because it has got the second hand. Option number D, a time interval of 4 minutes 10 seconds can be measured by clock A. No, it can only measure a time interval of 4 minutes, while it cannot measure 10 seconds.
Yes, sir.
Okay, then now we come to the NCERT exercise here. Okay, the questions in which you guys are having difficulty, we will be solving that, while the other ones we will be leaving it to you guys. Okay, before
Okay,
that, there was one important thing which I needed to discuss. That was about this pendulum. You guys know that when we talk about pendulum, there are few important terms like oscillations. Okay, oscillation is simply one complete motion done by the pendulum, that is called as oscillation.
Yes, sir.
And time period is basically what? Time taken by the pendulum to complete one oscillation. What did I just say? Time taken by the
Sir,
pendulum.
it's
To complete
by
one
the
oscillation.
bob, right?
Bob, exactly.
Yes, sir.
Time taken by the pendulum to complete one full oscillations. That is called as time period. For example, let's suppose that you have got this pendulum. It does 20 oscillations. Let's suppose the pendulum given here in this figure does, let's suppose, 20 oscillations in 20 seconds. In 20 seconds, it is doing how many oscillations? 20.
20.
So I need to find the time period, right? How much time it will take to complete just one oscillation. So
D
I
by
believe
T.
exactly. Time period will be total number of oscillations. Total oscillations upon total time taken. Total time taken. So in the question, total number of oscillation is how much, Sundus? 20
So
now.
what?
In the question, total number of oscillation is 20 now. It's 20.
Yes, sir.
And the total time taken is Vaiga. That is 20 seconds.
Yes, sir. 20.
So Chakrika, what would be the answer?
So 1.
1. So 1 second is the time period of this. Getting it now?
Got it, sir.
Okay, sir.
Okay. Okay. Guys, we need to put one thing needs to be rectified here. Actually, no, I just wrote it by mistake here. That time period, it's not like the total number of oscillations upon time, but it's rather than total time taken. Total time taken upon total oscillations. Okay, now. If you wrote it
Sir,
somewhere,
then
please.
also it will be 1.
Yeah. Then
I
also
think then
it will
also
be.
it will be 1.
Then also it will be 1. But here's the thing. 20 second upon 20, that gives you 1 second. But earlier we wrote it as 20 upon 20 seconds. So thereby we were getting 1 upon 1 second. So there's a difference between that now. 1 upon 1 second. Second was coming in the denominator. It always has to be in the numerator. And also the formula, correct formula is total time taken by the total oscillation performed. So keep that in mind.
Sir, like total time taken by number of oscillations, right?
Total time taken to cover the total oscillations, right? Okay,
Yes,
so
sir.
that is 1 second here. Okay, now let's come to the exercise part of the chapter. Question number 1. Have a look at the questions. The ones in which you are having problem, do ask me.
Okay, sir.
Okay, others will be left to you. You guys have to solve them. Yeah. Yes. No problem in first question. Chakrika, Sundus, Vaiga.
So what? You have to read the question.
Yeah, my question is that see the questions and see if you have difficulty in any given
Sir, what is
questions.
a seesaw?
Seesaw. Yeah, motion of a child on seesaw. It's like this now. I believe it's like this type of this type. In the playground you might have seen it, like it's mounted like this, I believe.
Oh, okay, sir. Okay, sir. I get it.
Remember, it's like that.
Oh, okay,
Yes, sir.
okay.
I don't understand like motion of a hard drive running. It says that it is oscillation motion, but it is a straight line, right? I'm not
Sundus, repeat which question are you talking about?
about the first one, motion of your hand while running.
Motion of your
It-
hands while running.
It is saying that is an oscillatory motion, but how could it be an oscillatory motion? It should be a straight line, right? So
No, look here. Whenever we are walking now, like we move our hands like this now. Like this now. Getting it now? Like whenever you walk fast, you move your hands in to and fro direction, in forward and backward direction.
When we are doing march, it goes.
March, exactly. Okay. Or if you were to see the parade, the parade, military parade. Okay, so thereby we also see the soldiers moving their hands in to and fro motion, forward and backward direction. So thereby they are doing it in a periodic way. No, it's a periodic type of motion. Thereby it's an example of oscillatory motion. Getting it, Sundus?
Sir,
Yes.
Yes.
so the fifth one is also an oscillatory motion, right? Hammer of an
Motion
electric bell.
motion of the hammer of an electric ball. Yeah, that is also an example of oscillatory motion, because that also does a to and fro motion, and the type of motion is being done in a particular manner.
Okay.
See in question number 2, 3, 4. Yeah. Do one thing now. Try to solve all the questions. The ones in which you will be having the problems we'll be discussing in the next class. Okay.
Sure, sir.